Okay, so last time we have seen the how to assign the RS configuration to a molecule. Okay. Again I just repeat before I go into solving some problems, that in the RS system what you have to do, that you have to place yourself in such a way that you look at the stereogenic carbon, and so that the group of the least priority is away from the observer, and then you see what is the sequence if you go from 1 to 2 to 3. If it is clockwise direction, then that is called R configuration. If it is in the anti-clockwise direction 1 to 2 to 3, then that is called S configuration. Okay. Now, let us practice few problems, 1 or 2 problems before we go into the next topic. That suppose a molecule is written in a Fischer projection formula. Say this is CO2H, this is CH2OH, and this is H, this is H, and this is M-methyl, and you are asked to assign the absolute configuration or the RS configuration of this. Okay. So, when you are trying to solve this problem, the first thing you need to do is to assign the priority sequence of the groups. Okay. So, if you do the priority sequence, this is the first atom, the carbon, this is also carbon. So, there is no distinction. Let us see whether there is any distinction between this and that. You can find the distinction because this carbon is attached to only one oxygen. So, that means this carbon is having hydrogen, hydrogen, oxygen. This carbon is having, this is, remember, this is C double bond O and OH. So, this carbon is having 3 oxygens basically, because C double bond O means you have to add one more oxygen to the carbon. So, 3 oxygens. So, that, and this is methyl, only 3 hydrogens, and this is only hydrogen. So, assigning the priority becomes little easier now, because the difference you find in the first atom, that is attached to the stereogenic center. So, this is number 1, this is number 2, this is number 3, and this is number 4. Now, some books you will find that they are written like A, B, C, D, that is also permissible. So, then you have to say that going from A to B to C, what is the directionality. Okay. So, then after assigning the priority sequence, you write in a simpler form, do not write the groups, just say that number 1 group is here, number 2 is here, number 3 is here, number 4 is here. Okay. And now see what, try to find out that what is the configuration. Now, here there is a slight problem, because in Fischer projection, you know, if you convert it into the wedge formula, then these 2 horizontal bonds are beta and the vertical bonds are alpha. That means, this is number 1, this is number 2, this is number 3, this is number 4. So, if I am looking from here, that means we are the observer from in this side. So, I am actually looking from the side of the 4th group, but in order to assign the RS configuration, I have to look away from the side of the group number 4. Now, how to deal with this situation? Now, it is up to you what you want to do. There are different ways people can assign the RS configuration. Some people do like this, that you know that exchange in a group of 3 is allowed. So, what you need is to bring the 4th group either in the horizon, in one of the vertical positions by exchange in a group of 3. So, if you do that, bring 4 here, 3 there and 2 there. So, that if you do that, you do not change the molecule, because that is according to the rule of Fischer projection, that is allowed. So, you do that and this becomes 4, that becomes 3 and that becomes 2. So, it is the same molecule, but now the beauty is that the 4th group is in the alpha position. So, if that is in the alpha position, that means what you see is, so if you convert it again into the wedge formula, you will see that it is in the right perspective that the fourth group is away from you. So, if the fourth group is away from you, then what you see from the top from here is 1 to 2 to 3, the direction is the actual direction that you should is the direction that gives the correct configuration. Or to tell in another way, that now if you see from this side, the molecule is held in the correct formula where the fourth group is away from you. It is alpha, that means it is away from you. So, now what is the configuration of this system? 1 to 2 to 3. So, that means it is in the anti-clockwise sense. So, this is the S configuration. So, the result is that this molecule that was drawn to was in the S configuration. Okay. Some people avoid this exchange. Now, this is what is called this is the original one, which is called the very good rule. That means, what you do, that if the fourth group is not in occupying the vertical position, you bring it in the vertical position, and then whatever you see, that gives you the R or S configuration. Okay. The other way to do it is that do not do any changes, just whatever is there, you just keep it there. So, basically this was our structure. The fourth group is now occupying a direction which is towards the observer. Now, remember that the very simple thing is that if I rotate, if I see a rotation, if I see the clock rotates in the clockwise direction, that is where the name has originated, okay, the clockwise sense. But if I look, if I could have looked the clock from the back side of the clock, then what I will see, that the clock is moving in the hands of the clock are moving in the anti-clockwise direction. That means, if I see the molecule where the fourth group is away from me, if the direction 1 to 2 to 3 is clockwise, then if the fourth group is towards me, that clockwise will become anti-clockwise. Like if there is a fan rotating in the ceiling, and if you see from the bottom, the fan is rotating in a clockwise direction. If somebody looks from the floor to the same fan, to him or her it will appear anti-clockwise. So, if you remember that, then there is no problem, your fourth group is here towards the observer. Now, the 1 to 2 to 3 is in the clockwise direction, but you remember that basically the fourth group is towards you. So, whatever you see, you actually reverse the direction. So, basically 1 to 2 to 3 is in the clockwise sense, but you have to write this when you write an answer, since fourth group is occupying horizontal position. So, actually the configuration should be S. So, whatever it appears, you just reverse it. Okay. So, it is up to you what you want to do. If you want to bring the fourth group in the vertical position, you do that, otherwise you can keep it in the horizontal position, but then remember, whatever you see keeping at the horizontal position, we have to reverse the direction. Okay. So, that is the RS. We can actually do more problems, but I think the some other cases I can tell you where you might face some problem is, we'll go to this section later on, but you know what is the molecule cyclohexane. Okay, the cyclohexane is the planar form, it's the, we write it in the planar form, but actually this exists in the mostly in the chair form. Okay, mostly in the chair form. And suppose there are two groups, here there is a methyl, there is a wedge, and suppose there is a methyl here. Now, this molecule has two stereogenic centers, one is here, another is there. And if I ask now to do the absolute configuration of this carbon, absolute configuration of this carbon. So, what you do first, try to assign the priority. This carbon is attached to OH, so oxygen, this is attached to carbon, this is attached to carbon, this is attached to carbon. So, this must be your number 1. And what is the number 2? Number 2 is, this is the carbon CH2, this is also CH2. So, there is no difference here, but then the next carbon going from this side is a carbon attached to 2 carbons. Here this carbon is attached to only 1 carbon. So, this gets preference, that means this is your number 2, that is your number 3, and this is your number 4. So, now how to assign the configuration? Now, again, if you are a very good, if you have good concept about 3-dimensional structures, because you have to look from this side and then see what is the direction going on, 1, 2, 2, 2, 3, okay. You can do that. Those who can see it visually very clearly, they can tell what is this direction 1 to 2 to 3. But I can give you some what are called mnemonic devices. Mnemonic devices means some simple way of doing this. Those who cannot visualize very well a 3-dimensional structure, for them this rule you can apply. This is a mnemonic, this is not a rule, this is just for the sake of, these are called mnemonic device, so that you do not have to think much, but you can arrive at the right answer without going into the complexity of the 3-dimensional structure. So, what is this mnemonic device? That what you do in cyclohexane, when you write the chair form, interestingly some angles appear bigger than the others, although all our angles are 109 degree 28 minutes, but some angles do look, because this is a 2-dimensional perspective formula. So, some angles will look like smaller than the others. Okay. So, this one looks the smallest amongst all these 4 angles. So, the mnemonic device says that you look into the system standing in between the bonds which appears to make the smallest angle. Okay. That means, I am standing here. See, if I stand here, then what happens? These 2 bonds are towards me and towards my right hand, left hand, and this is a sorry, I am actually standing, I am standing here in between this. Okay. So, this is my position, and this is my position of the 2 hands. Okay. Suppose this is a person. Okay. Let us say these are the hands, these are the legs. Okay. So, this is the right hand, this is the left hand, this is the head, and this is the leg. Okay. So, I stand here, if this happened to be me, I stand here and then I look at this carbon. So, if I do that, what happens? These 2 bonds are towards my hands and towards me, and these 2 bonds are away from me, and they are occupying, one is going towards my head and the other is going towards my leg. Okay. So, now you can easily draw the Fisher projection directly without drawing the atoms. Better draw the priorities that you have already assigned. So, which one is the number 2 will go towards my right hand, number 3 will go towards my left hand, number 4 will be at the top, number 1 at the bottom. Okay. So, you stand, the rule is that, the mnemonic rule is that you stand in between the bonds which appear to make the smallest angle. But I repeat, this is all the angles are 109 degree 28 minutes, but when you draw it in the 2-dimensional projection, it appears that one angle is very small. So, now you stand in between, spread your hands, and it looks like just like the Fisher projection and the way it should be in the Fisher projection, and you draw the Fisher projection. So, on the right is 2, left is 3, 4 is at the top, 1 is at the button. Okay. Now, since 4 is occupying the horizontal, the vertical axis, so whatever you see, that will be your configuration. So, it is anti-clockwise, that means this is S configuration. So, if you want to do the configuration of this now, this carbon, this is the other carbon. So, according to that mnemonic rule through which you should see, this angle appears to be the smallest. So, you stand here and look from there. If you look from there, as I first assign the priority, this is the carbon, this is the carbon, there is no difference because this is CH2, that is CH2, but then you find a difference, CHOH. So, this should be 1, that should be 2, that should be 3, and that should be 4. So, if you do that, now you look from this side, it looks, it is just the way it should be in the Fisher projection. So, you write the Fisher projection. On the right side is 3, on the left side is 2, on the top side is 4, on the bottom side, sorry, 4, and on the bottom side is 1. Okay. Again 4 is occupying the vertical position, so you do not have to change anything because it is now away from the observer. So, whatever you see 1 to 2 to 3 is the correct designation. So, it is R, you do not have to invert it. Okay. So, this is some of the tricky situations, especially in cyclohexane system when it is written in this form, or in the same thing will happen in if you draw it in the sawhorse also. The same thing, if you try to draw it in the sawhorse formula, the same thing will be applicable. So, what I say that you always see it in a fashion which gives the lowest angle. Okay. So, that is a kind of mnemonic. That is, it's the hard and fast rule that you have to do it, but I think for beginner, for students who are at the beginner stage, for them this will be very helpful. Okay. Now, let us go away from this RS. So, we said that we will also do the relative configuration. Relative configuration, again I say there are two types of relative configuration. One is that if you do not know the configuration, absolute configuration of a molecule, you try to correlate. That means, you convert one molecule which is of known absolute configuration into your target molecule for which you are trying to determine the configuration. Then if you can convert that, then you say that okay, it has got this configuration because it has come from the original compound for which the configuration is known, but this is actually the relative configuration because there is no direct proof, direct X-ray crystallographic proof for the configuration of the other molecule, that I have explained earlier. Another type of relative configuration I said where there are multi-stereogenic systems, then the relative configuration is basically the configurational relationship between the two stereogenic centers. Like suppose one stereogenic center is R, another is S. So, or this is R, this is S, this is R. So, that means they have opposite configurations. If that is the case, then the situation becomes a case of relative configuration. That if I say that draw a tartaric acid where the two stereogenic centers have opposite configurations. Okay. So, this opposite configuration means that I am talking about the configuration of one in relation to the other. Okay. Again, there are nomenclature systems for relative configuration, and that started from again the carbohydrate. You remember the DL nomenclature system started from the carbohydrate, that Emil Fischer assumed that plus glucose in the D configuration, and he said what is D? The last stereogenic center, if the OH is on the right, then that will be called the D configuration. Okay. That is just an assumption. Fortunately, when the X-ray crystallography was done, it was found that Fischer was right. So, whatever structures he had given for other aldohexoses, other carbohydrates were all right, but if he was wrong, then the literature had to correct all the structures what he had given him based on the configuration of plus glucose. But fortunately, it was found later on by crystallography that Fischer was right in his assumption, but that is purely a coincidence. Okay. Now, this relative configuration, there are different ways to designate relative configurations. One is called trio-erythro. Trio-erythro. So, what you then another is called like unlike. We will not we will discuss only few. There are many ways to describe this configurations, relative configurations. What is a trio configuration? The trio configuration is that take this carbohydrate, this sugar molecule. The sugar molecules are basically the polyhydroxyaldehydes. Okay. So, if you see that these OH groups are opposite to each other in the Fischer projection formula, then that is called trio. Actually, this molecule is what is called triose, and the molecule where both the OHs are on the same side, that is called erythrose. That is called erythrose, and based on this, if I draw a molecule which has got, suppose this is OH here, this is CH3, this is C2H5, this is OH here, this is H here, this is H here. This is not triose or erythrose, this is a different molecule, but because these OHs are on the opposite side, so that will be called a trio molecule. Trio, and then IUPAC nomenclature whatever, this is actually 2,3-dihydroxypentane. So, trio 2,3-dihydroxypentane, trio 2,3-dihydroxypentane. So, you can write the, but remember, if I ask somebody to write the structure of trio 2,3-dihydroxypentane, he has to write, he or she has to write two compounds for this, two structures for this, and you cannot, because this one is also trio. Both are trio, because in both the cases OHs are on the opposite side. OHs are on the opposite side. Okay. So, that is this is trio. So, in the erythrose, both the OHs are on the same side. So, again if I ask you to write erythro 2,3-dihydroxypentane, you have to write two compounds. That is why this is called relative configuration. See, it is not absolute, you cannot absolutely tell which one is the compound that you are talking about. Okay. So, this is trio-erythro. There is another one which was introduced by a Swiss chemist, his name is Seebeck. Seebeck gave another way of giving a nomenclature, relative nomenclature for relative configuration. See, the problem with this trio-erythro is that if you do not have this OH, suppose you have some other group, say this is chlorine and suppose this is C3H7, then which one is trio, which one is erythro? That is a problem. So, unless you have heteroatoms like OHs or suppose two chlorines, that is still okay, but this is mainly trio-erythro is mainly applicable for these OHs. So, if you do not have OHs, if you have alkyl groups, all alkyl groups or other groups, say chlorine, then another fluorine, then it is very difficult, you cannot actually assign trio-erythro configuration to this system. So, trio-erythro is not a general nomenclature system for relative configuration. So, realizing that, Seebeck gave another way to designate the relative configuration, and what is that? Let us see, I go back to the original molecule. suppose I have two molecules OH, H. In the threoerythro system, this is the threo compound and this is the erythro compound, because the two H's are there. In Seebeck system, what he says that you determine the RS configuration of this, RS configuration. So, what is the configuration of this carbon? So, this is 1, that is 2, this is 3 and this is 4. 4 is occupying the horizontal line. So, you have to be careful. So, what is the configuration here? 1, 2, 3. So, that means this is actually S, although it looks like clockwise, but hydrogen is on the horizontal side. So, this is S. What is here? This is 1, this is 2, this is 3 and this is 4. So, here again hydrogen is occupying the horizontal line. So, whatever you see, you have to reverse it. So, 1, 2, 3 is clockwise, but actually it should be anti-clockwise. So, this has got SS configuration. Okay. So, now he says that if the configurations of the two centers are similar, like SS or RR, then that will be called like system. Okay. And if the configurations are different, like RS or SR, then that is called unlike system. So, see, you do not have to write all those 6 letters. So, you just write U is unlike, UL, and this you write only L, like. So, instead of threoerythro, now he says that do the absolute configuration. So, if I say that okay, write the structure of like, that means L 2,3 dihydroxypentane, actually LK, I think like is LK possibly, unlike is UL, then or write the full name. So, write the structure of like 2,3 dihydroxypentane. So, that means whatever I write, this 2,3 dihydroxy should have RR or SS configuration. Earlier it was threoerythro, now it is like unlike. Okay. I will clarify this, whether what is the convention, whether it is right LK or only L, because L has this lever rotatory thing in mind. So, possibly this is LK and that is unlike, that is UL. Okay. That is unlike. So, this is the, these are the two nomenclature system for relative configuration. So, what is the difference between absolute and relative? Absolute means you write only one configuration, one molecule. In relative, you have to write two systems, means in multi stereogenic centers. Okay.